Hello, I'm Chris. I'm a KMP developer. Tech support says they're coming out for that thing. Yeah, but we'll see, right? All right, I'm going to do a watch along with you. I've only previewed this a little bit. OOP then and now. And yes, there are two different OOPs. There's the class, if you go to my free course for how to program from the ground up on my GitHub page, which I will leave a link below on. There's two types of OOP. There's the class-oriented programming, which came through C++, that stole the label and jammed as many features as they could into C++ as possible, and you have to know every single one, even though they're half-cooked and don't really work exactly how they're supposed to be. And there's the other style, which comes from Alan Kay, which is small talk, coming from the small talk thing, which is more about messages, not about classes and inheritance and all that. It's more about having things encapsulated as if there were cells, and they only send messages in and out of the cell. You can't just grab inside the cell and pull something out like a static variable. So there's two. There's class-oriented and the original object-oriented programming, which is OOP, or I call BOOP, back to object-oriented programming. So I think this is going to touch on some of these subjects, and let's get started. So I'm a Kotlin primary, so he's going to bring out some other languages, but here we go.
Recently, I've seen a pretty significant change in the approach to OP, and this has become apparent on some languages like Rust. I want to go into a deep dive. Recently, I've seen a pretty significant change in the approach to OP, and this has become apparent on some languages like Rust. I want to go into a deep dive of how OP is evolving, which will make you understand OP more fully, and able to utilize the good from OP and discard the questionable. I'll discuss the main conflict in OP and several other things that get changed in modern interpretations of it. This is specifically the structure of this video. First, its original vision. Second, what the conflict is, and also what a modern interpretation of OP looks like. Finally, what you should take away from this video, also how you can apply it.
Yeah, so the kind of style I work with all my apps that I have on my GitHub has been in this Alan Kay Boop style, and they all have that idea, mindset behind it. Like there's certain things we don't do, like there's no static variables. You can't just grab inside of a class and pull something out directly. It all has to be going through messages. Here we get this. So I fully incorporated this style that I think he's referring to. I've incorporated it because there's a lot of stuff in OP that people say was the most amazing thing ever, and it was just a continuation of the last thing because people couldn't wrap their mind around what Alan Kay was talking about with the messaging system, and they got on top of this. Oh, I can inherit and you reuse code with inheritance. We can reuse code, and like the whole Android system is built on top of that idea, and it's like, yes, it had to be abandoned. Like most of it's been thrown away. KMP is like a really good example of Alan Kay's style. So let's keep going.
Before OP, the popular high-level languages were languages like Lisp. OP itself was invented in the 60s. Alan Kay got the idea of objects from biology and described it like cells making up a living organism.
Right. So when they mean object, it's like everything is an individual little entity, an object that you have to talk to with messages in and out. And by keeping these entities complete, like microservices, the idea of microservices, like keeping these things, like there's an API you talk to. You can't just jump inside it. You can't hack inside it. So you have to go, everything goes through the API so we can control everything. And whatever's going on inside this black box could be another language, a whole other system. But if you only talk through the API, then it emits a whole, it totally eliminates a whole class of bugs, a whole class of issues around Conway's law, like how you organize work, all that stuff.
These cells communicate with each other through messages and have implementation details, which you don't need to worry about, which is...
Well, you need to worry about them. Well, you have to know what the thing's supposed to be doing inside, but how it does it, yes, that's bound to be changing. How it does it, now what you want it to do, yes, you have to... It's like, you don't have to worry about... Well, you do have to worry about how that stuff is implemented, like one library versus another one. Is it using breadth first search? Is it using quick search? Yeah, you do have to know kind of like some things that are going on inside, but you don't want to know all the details. That's the thing, is you don't want to know how all the things are going on and all the different API requests that it's doing to get its work done with its proprietary APIs. You want a public API that you have access to, and then whatever else is going on, like, oh, I'm going to hack my way in. It's like, okay, that's not sustainable. Yes, you can do that. Yes, you can even hack into all these different things, but that's not really what we're looking for, right? We're looking for having systems that are maintainable, that can be modified, that are easy to understand, are not super complicated. There's not 50,000, like if I change something over here, it's not going to change 1,000 things over here because I don't even know why is that thing linked up. Where was that link published anywhere? We have no idea because someone hacked in. Okay,
encapsulation. To him, messages were the main feature of OOP, not classes.
Correct.
Developers soon discovered that it was really convenient to represent elements in a user interface as objects. This is why OOP got popular in the first place.
I mean, it was one of the reasons. Actually, the OOP, the original OOP, with having these little objects, it was for simulators, for simulation, like simulating hospitals, simulating traffic, simulating lots of little items that are doing things in a system. It was for simulating that stuff, and they realized, oh, we can do user interface elements the same way. Yeah, I guess you kind of could. I guess you could apply that there, but it was really meant for this other thing, this simulation thing from Simula to simulate real world types of objects, actual real world objects, not user interface items. But that's I got co-opted. So a lot of this stuff is like, oh, we got this over here. We can use that to do this other thing over here. And it's like, well, and then they get to this thing. It's like, okay, we do generalized user interface. Well, maybe not. Maybe not the way we've set it up here, where we've just gone to this one link. It's like we can't. You want to do this another jump, but it's like maybe this isn't really designed because it came from this thing, that came from this thing, that came from this thing, and we're still trying to get all those developers who are still using this chain of things that have happened so far. They're the main ones because they're the ones in the thing trying to make it better and realize there's all these limitations for it. So it's a lot of times we get these constructs that were like presented like this guy's like, oh, OP came from user interface. No, it really didn't. It came from this other thing, and it was promoted as a way to solve one of the problems because of the reusability. So everybody's like, the managers go, well, reusability? You mean I can leverage the code I've already had written that costs millions of dollars? I can reuse it again if I just get an inheritance hierarchy? And that's where how this thing was driven. A lot of this stuff was driven because of sales. I know it's shocking. I know it's really, I keep bringing this up in all my videos, but people like have a real hard time with this one. It's like, yeah, this is money. People's businesses. This is sale. This is someone hearing an objection and go, oh, I can apply this thing over here to this, and you can get my sales done because this company's going under. And if we don't have a new product soon, we're about to go under, and it doesn't matter anymore. And if you go listen to the interviews with Stroopstrup or whatever the hell his name is, about talking about C++, why it needed to happen is because it was about to die. His language that he was working on was about to die unless he started to jam a bunch of features in there. Selling this thing, yes. Does it slice bread? Yes, it does. Does it toast it too? Yes, it slices and toast bread too.
This was also around the time that GUIs got popular, and a lot of
that was synchronous, similar thing, but it was really Alan Kay stuff, not the way people reinterpreted Alan Kay stuff with this weird C++ thing. People are like, no, like Smalltalk, it's too slow. Well, yeah, on that hardware, it was slow, but if you ran it today, you would not be able to tell the difference because it's just the same. It would be the same thing today, but the ideas got in the way, right? People did not want to let go of their highly efficient C++ code. They couldn't get the performance wasn't there yet, but the performance is there now, and people still want to eke out the most amount of performance, so they have to go down to C++. I get it. But that style of programming is causing a lot of other problems like maintainability, which is most of the costs involved with these things. Yes, you're going super fast, but we can just like put that thing to the side, and the rest of the application is written in some other thing. It does not have to be super tied to the hardware. No, make it so it's maintainable so we can understand things, not static variables all switching each other. Now, if you're looking for job security, that's a good plan. But if you're trying to maintain code as a business owner or small SaaS developer, and you need to actually get something that's going to maintain it's going to maintain its integrity over time, well, we're going to have to like step away from the C++ mindset.
Frameworks were object-oriented. OOP as a paradigm got even more popular when Java was released. And as it got more popular, it got more and more modified. To Alan Kay, inheritance was not even considered when designing OOP.
Right. C++ is an extension of C. So it took some of the ideas that Alan Kay was talking about and slammed it into C because they could say, we're going to be performance plus the stuff in Smalltalk. Like, yeah, I don't know if that's the thing, man. So people are like, no, you just shortcut that with static variables. Like, okay, well, you're missing the whole point. You're missing the whole point of what you were trying to get out of this object-oriented stuff. And Alan Kay is correct. It was not C++. C++ is this whole other bastardization that got picked up AT&T trying to save their bacon after their telecommunications business died.
Not only was inheritance not considered OOP, neither were classes or polymorphism. Correct. This shows that the vision of OOP is very skewed. A language much closer to the original vision of OOP is Smalltalk or JavaScript. Something like Java is not...
Yeah, like JavaScript. People hate on JavaScript because it's like, unless you understand like the nature of where it's coming from, the Smalltalk, everything's an object, everything can be changed at any time. Yeah, it's going to be like, what the hell is all this stuff? It's like, Yeah, because you're coming from a C++ C mindset. It's going to look procedural mindset. It's going to look very odd. It's like, why are you doing all this stuff? It's like, well, when you have a billion of these things, or 1,000 of these things, and it's good to have things like you don't have to want to know all implementation details, and you want to be able to swap them in and out with an interface. So that's some of the ideas that Alan Kay was playing with they saw were the problems that were happening from the procedural approach. Oh my god, this
even close to being object-oriented if you go by the original vision and definition. Which means that OP is not OP anymore, which makes you wonder, what even is it supposed to be?
COP. There's the COP. The classes, inheritance, all that's COP. That's COP. That's the C++ bastardization of what were edge case ideas. The main idea was to create everything has to be doing through these messages. So yes, there's going to be some overhead on sending messages around, as opposed to just jumping in and access the variables directly. But also jumping in and access the variables directly means every place you're doing that, where you're jumping in for speed, means that you're going to go change all that stuff if you change this one thing. And multiply that times 1,000. That's the problem. That's the issue. We're like, why is our project stuck? Why can't we modify it? Why can't we fix it? Why isn't we make one change here and there's 10,000 places? Because we are being performant. So crazy. Anyway, we're about due for this is going to be disrupted soon, one way or another. We can't keep going forward this direction. This is the dead end path. The C++ approach is the wrong one, but the stuff that Alan Kay, we will have a revolution that will actually make the current one look silly, because the way these operating systems are structured right now, where you're all black boxes, you can't actually get inside them, and they're all proprietary and all. That's not going to go. That's not going to go away at some point because that's just unsustainable.
Some people think that it needs to be changed, others that it isn't necessary at all. I will explain the modern ways of interpreting OP. The major distinction that divides modern OP is composition versus inheritance. And both of these are a way to...
Okay, I mean, I hate that way that they say composition versus inheritance. Okay, yes. Individual little objects that send messages to each other that can be encapsulated, that can send messages to that group of that message objects that can send those. Yes, that is what the composition. It's like, how about just like organic hierarchies, where you have these objects that talk within each other, and that was the idea. Not let's go inside and grab a static variable and call it static function. It's like that's not the idea. That's not the idea.
Describe a relationship between two objects. Most developers agree that objects are very good, but they disagree on how to implement relationships between those objects.
Right, because the way it's taught, and because it's still the procedural style. Everywhere I've been, except for Alan Kay, when I really took the time and listened to the 40 or 50 hours of his lectures, I finally sunk in. And also Bugayenko, when he was like, okay, we're taking the Alan Kay stuff, we're actually making something real with it. Like another 80, 100 hours of that guy yelling at me. It's like, yeah, the way it's taught, the way we teach computer science in academia, you're never going to get the Alan Kay stuff. You're going to get the C++ stuff, because it's like, the procedural stuff is like this, but this. And I go in this in my course, by the way. I go into detail about how this works.
Composition is
so you can do the intro, and then you can go deep dive into those other guys, because I kind of like break down some of the stuff they're talking about, because they're kind of long-winded. They're even more winded than I am, because they have to try to explain all the little details, which they do a great job of. But unless you have an idea of, like, if there's a guy named Bugayenko and he's talking about this stuff, you're never going to... I stumbled into it because I'm like, this can't be the way we're seeing... This is an object-oriented program. I look at Alan Kay stuff. I'm like, the way we're doing this is all procedural stuff. It's like, well, yeah, I guess it's procedural. It's like, but you guys are calling it, it's OOP. It's like, okay, that's not OOP. So we have to have two words. We have to have class-oriented programming, which is a C++ style, most of Java, and then we have the Alan Kay style, back to object-oriented programming, the BOOP style, and then that's more the Alan Kay, what he was talking about. You can look at I've got a couple examples of it on my GitHub. So there we go.
A relationship between objects where object A has object B inside it. The other type, inheritance, is a relationship where object B is object A, or explained with an example.
I hate this terminology. Is? You mean they're equal? Then why do we have one and the other? Man, this stuff is so goofy. Like the way we're using these words now, no wonder we're so confusing.
Or is a vehicle. Composition is actually a lot closer to the values of original OOP. Even in the famous Gang of 4 OOP book, the authors recommend composition in most cases.
Yeah.
If you have a computer science background...
With designing an application that way, that's performant. Yeah, there's going to be messages thrown away all around all this stuff all the time. and there's gonna be stuff that's inside there that you want to get access to. It would be make more convenient. It's like basically the same stuff as microservices, except it's inside your code. So if you write your code that way, it makes separating out these services really a lot easier. But if you're trying to dig into everything because you need to have 0.6 seconds faster, it's like, well, you're breaking the rule that makes it so this stuff can be maintained and can be extended and can be changed easily. We're going to make a performance. Like, well, you're going to give up a little bit for more performance for most of the problems you're going to be having down the road, which are not about performance. Like, we're going to get the performance boost with these chips running faster. And people don't even care about that stuff. It's like, can I make a change? Can I change this button over here without making all the buttons here red? No? Oh, Jesus. Okay,
you probably thought that you should use composition or inheritance based on how they would be in real life. But not everyone agrees with this approach, which
What does that mean in real life? What other life do we have? What are you talking about? In fantasy worlds? Okay,
I'll go into later. Composition tends to be more flexible and less rigid, and this is mostly because you choose what to inherit. You can also make yourself less dependent on the parent than inheritance. Inherent in quotation, you don't really inherit, you just override. And the other one, inheritance, isn't really that flexible compared to composition. This is because you inherit everything, you don't choose what you want to inherit. You could technically override the methods you don't want to inherit to do nothing, but this isn't really a great way to solve it, since developers expect those methods to do something. And recently, people have been preferring composition over inheritance in general, mostly because of the added flexibility. What's even more interesting is that some languages have actually been leaving inheritance out entirely, and I'll give an example on this later.
I mean, you can. I mean, if you're gonna use inheritance, maybe you should have it maybe 2 layers of hierarchy max. Otherwise, like, what the hell are you doing? Like, why are you making it so complicated? You should have 2 layers of that stuff max. And nobody ever said that. So we have these massive long chains of inheritance. And it's like, well, it's getting this thing from here and this thing from here and using this thing from here and using this thing from here. It's like, really? Is this the way you're gonna? And this is maintainable code. So it's like, I can't make any changes. I'm gonna gotta make a new hierarchy. These have the same problem 3 years from now. Keep going.
I'll demonstrate why this distinction matters on an example in C++. This is just regular inheritance. The only thing to note here is the virtual keyboard, which is necessary for something called dynamic dispatch, which is just the C++ way of overriding methods.
Okay, all right. So this thing, public B. Okay, so public class A is a class. So class B inherits from class A. And it overrides this thing. It changes even. Okay, it doesn't change the signature. It says, okay, dynamic dispatch. Like, all these goofy names with this stuff. It's like, okay, this just means like, if I use a B, I'm going to call this function, not this function. Ooh, it's a dynamic dispatch. No, it's different. Like, I've heard actually so many people say, no, it's not that. It's like, I mean, just like, it's a pointer to a function. No, it's dynamic dispatch. It's different. It's like, okay, buddy. Like, there's so many spurgs that really get focused in on the definition, the word meaning, what they think this word means. It's dynamically dispatched. It's different. It's like, no, it's just, I'm going to call this function instead of this one. Dynamic dispatch. They make it see that's one of the things also that you're getting fucked with with these guys, with these pushers, these languages. When they have these goofy language like this, it obfuscates. It makes it seem that's real fucking simple. Makes it seem like it's a real big deal. Ooh, you're being sold. And just be aware, like, hey man, there's a lot of sales going on. This is like sales driven thing, man. We would not be using C++ if it wasn't for AT&T with the telecom system failing, their telecom monopoly failing. We would know nothing about C++. It would be dead. It would be gone. We'd be using Smalltalk by now.
Here we run into a problem. If someone changes the return type of do something, we get an error in B. You would have never run into this problem if you use composition, and this is the example with composition. As you can see, you can change the return types without an error, and that's...
See, I mean, okay. I mean, that's one reason, I guess. But really the reasons are ones I've listed in my course. Okay. Let's keep going. This is still the sickness of the procedural. Like, oh, it's this, you have to be this. It's this other thing. It's like, okay.
Point though. The overall point is that composition is less coupled together, whereas inheritance is strict in terms of coupling, and there are a lot of advantages to composition, but the last one that I will mention is access control. With traditional inheritance, we inherit everything, but with composition, we choose what we want to inherit. This is extremely useful when you're inheriting from large classes, where we only want to select a few methods. A good example of a language with a modern take on OOP is Rust. Rust is the OOP without inheritance. The founders of Rust created this to capitalize on all of the good of OOP without the bad, which inheritance is widely considered as, and here's how the Rust book describes how Rust handles
the Rust, but okay, I have not looked at Rust at all. I don't know anything about it. If a language must have inheritance to be object-oriented language, then Rust is not one. I don't think you need to have inheritance to be. I don't think it's necessary. I think for having a simulation, yeah, you gotta have class hierarchies if you're doing simulations, right? You gotta have a person. He could be a janitor, or you can have a truck, and he could be a dump truck or a trash truck or an ambulance. Yeah, it makes a lot of sense, but not in general. It's just a tool to organize your code and organize your functionality. What you're trying to do is a convenience, not inherently thing that needs to be the thing that makes it the thing. It's like that's all. These are all ideas anyway. These are all just ideas anyway. And people like Spurgy, fucking autists, which I am included in this group, we love to like look at the definition thing and then make up our own definition, because when you actually try to define it, you get a lot of baloney. Like, it's this, it's that, it's the other thing. It's a lot of opinions because it is opinion. And people want to make it like, no, it's this. It's like, no, it's just an opinion, man. I know we want to be like, no, it has to be the thing. It's like, this is just an opinion. Hey, if your C++ code works and you perform it, you got $1 million contract because your code works 2.6% faster than somebody else, then you got your you found your customer. You found your niche. And some people are totally down for that, right? And it's like 75 people. But they're all very loud because everyone's like, oh, if I can just make it faster, I get $1 million contract. Autists love that, right? Autism and Asperger's like, all you do is make it twice as fast, and I get the $1 million. Okay, I can do that. It's like, but can you make it twice as good? Can you make it twice as easy? Can you make it twice as easy to fix, to maintain, to understand? So I don't have to have a fucking PhD just to debug your code. Can you make your statements, your log statements, make sense, have some kind of context? But what went wrong? Why? For what record? Nope, error. It's just error not minus 64. You'll figure it out. Go look it up in the manual, like I had to.
It's OP.
It's a lot.
Also, here are some reasons why someone might.
Very unhuman. A lot of stuff in technology, this computer science. I mean, when I first started, it was very human. But what it's turned into is that's not how he talks. Like a robot, man. Come on. We're making code for humans. I know it's really hard to believe. It's like, no, I'm writing for the code for the computer. It's like, no, we're not really. No, unless you're doing computer engineering stuff, and even then, you're still writing for people. And it has to be maintained by people who are human and get confused pretty easily, especially if you're trying to confuse them.
Consider leaving inheritance out of a language. The gist of this is that it shares more code than.
Inheritance has recently fallen out of favor as a programming design solution in many programming languages because often at risk of sharing more code than necessary. Yes, that's a procedural. I've seen people who struggle with where do I put in my class? And they're just writing a procedural thing. It's like, that's not right procedural, man. You don't need object-oriented for pretty much most things. You don't need object-oriented stuff, man. Just write procedural. Just think procedurally. And you'll probably be all right. Now, when you get to bigger systems that have to have different types of things in there, and the behaviors of those things are changed, then yeah, you might have to use objects. It's like round peg, square hammer. Okay. It's often a risk of sharing more code than necessary. Subclasses shouldn't always share all characteristics of their parent class, but will do so with inheritance. Exactly. You take it all. You get them. I just want the banana. You get the monkey. You get the tree, you get the forest, you get the continent. I just want a banana. All right. Subclasses shouldn't always share all characteristics of the parent class, but will do so with their inheritance. Yeah, this can make a program's design less flexible. Yeah, no shit. How about inflexible? How about like, okay, while you're writing it, it's a little bit less flexible, but like when you're coming into it fresh, someone trying to figure it all out, like most of these legacy projects most people are assigned to, where you're just fixing somebody else's bad ideas and bad implementation and misunderstanding, confusion. You have to figure out, okay, well, is this person confused or they advanced level shit? Like, which is it? You know, usually it's somebody's confused.
Then it's often necessary and it makes the program less flexible. Even Carbon, which plans to be a successor to C++, isn't abandoning inheritance.
It says Carbon's take on inheritance. Non-polymorphic inheritance. While it's not common, there are cases where C++ code uses inheritance without dynamic dispatch or a vtable. Instead, methods are never overridden. Derived types only add data and methods. That there are some cases where this is done in C++. A bit is been done differently in Carbon for implementations reuse. I've never even heard Carbon C++. Why never? No one's ever going to displace C++. Come on now, they're not going to be around forever. For implementation reuse without subtyping, Carbon code should use mix-ins or composition. Carbon won't support private inheritance. Okay. Carbon will allow data members to have size 0, so the empty base optimization isn't necessary. I don't even know what that means. For cases where the derived type does not add any data members, in Carbon you can potentially use adapter types. I mean, Kotlin has extensions. I guess that's similar. I don't know. Everyone uses these words differently for inside of each language. So each language they'll have a different name for this. So now they're saying C++ dynamics or vtable. So what's it call it both? Let's pick one name, guys. Can we pick one name? No. So we don't have. So this is another thing that shows you we're still in sales cycles with this stuff because everyone's defining words differently, and that's where people get real hung up on all this stuff. Because unless you go down to the dirty details of what they're actually meaning to say here with mix-ins and all that and composition, like what are you talking about exactly? Because everyone's got a little bit of different take on it. So then we this creates flame wars. Keep going.
But it is restricting the use case of it. I would argue that this is the most important distinction in modern OOP implementation, and I expect that a lot of newer languages will ditch inheritance, or at least restrict it. To be slightly different, I'll use Go for this example. I want to talk about another feature of OOP that is now often missing. Also know that Rust is doing basically the same thing. What I want to talk about right now is the removal of constructors. The issue constructors have is that you can have 5 different constructors, and they all have the same name, with no indication of what combination of arguments.
I mean, Kotlin has a little different take on this, which is a little bit better. I mean, there are times when I need to create something with a name and the address will be filled in later, or just the address and name and the email is not. I mean, you can have multiple constructors. Yes, it's convenient. Who cares? Why? Okay, well, this is a non-issue.
Arguments make what? You could have a constructor with 3 strings and another with 2, but you would have no idea what the difference between these 2 are.
Right, because it's not named parameters. I mean, Kotlin has named parameters, so you just name the parameter. X equals this, but B equals Y. This is a non-issue.
This is actually why Go prefers to use functions that act as constructors. Because of this, you can have different.
What I mean, a function. Okay. This is like splitting hairs. This is some bike shedding shit.
Constructors with different names. Carbon is also moving away from constructors in the same way. And I can give you an example of this. Take Java's scanner class, for example. There are a lot of constructors, all of which do something different.
Yeah. Yes. They all do something. These are all convenient. Because it's just like sometimes you want to do this, sometimes you want to do that, sometimes you want to do this. Sometimes you don't have all the things values to put in already. But this is a non-issue.
It would be slightly more verbose, but easier to read if, instead of them having the same name, they would have different names. With the origin.
I mean, you can do that too. Why not? I mean, wait. I don't know. You can, but telling from the context with the named parameter, you can kind of tell what's going on. I don't know if you need a different name for. I mean, if you really want to, I guess you could. If you turn a new object, I guess. I mean, you could do that now.
Original, you have no idea what the second parameter would be if you just saw someone call it. And if the variable
because it is not named
was from a class 20 levels deep into inheritance and probably named, you wouldn't even know what the first argument was. In the modern way of doing constructors.
Yeah, this is garbage too. This is
from a class
C++ bullshit right here. This is all C++ bullshit. No, this is coming from people come thinking procedurally and they're told that C++ is the way to do it. They jam this stuff into a class and they hope it solves their problems.
Levels deep into inheritance and probably named, you wouldn't even know what the first argument was. In the modern way of doing constructors, the file constructor could just be called scanner from file and the second variation scanner from file with charset.
I mean, if you have named parameters, it also becomes an easier thing. So, I mean, you could do this now. I mean, with Kotlin, you could do that stuff. I mean, okay.
With this modification, it's obvious even if you don't know what the variables are, even if you don't know what the types are. The interesting thing
should make it that way. I mean, that's not a bad thing. That's a pretty good idea. But why does it be part of the language? That's okay, whatever.
Is that these changes aren't anything new. All of these changes are a return to the older way of doing OOP, the definition that I showed in the beginning. Also, these languages removed a lot more from OOP. Yeah. These are just examples. I think current OOP isn't horrible. I think the modularity and abstraction it offers is extremely useful. But I think a lot of the changes to OOP in languages like Rust, Go, and Carbon are a step in the right direction, and I predict that a lot of languages will follow this change. In general, the modern programming paradigm will probably become a blend of these paradigms. For you, this could mean different things based on who you are.
Yes, it's just tools in a toolkit. That's what Kotlin took this approach, is multi-paradigm. You can do switch in, switch out, all kinds of stuff for different ways. And yes, it's like it just depends on the project you're doing, man. Just depends on the project you're doing. There's no perfect solution. It's always like Thomas Sowell says, it's just trade offs, man. It's just trade offs. There's no solution. It's just this way, this is the other way, and having more options in your toolkit. And maybe we don't have to use an OP for this particular. Maybe we just use procedural here. It's fine. It's just some batch process. We don't overcomplicate our lives. Make it easy. Make it easy on ourselves. All right, give me a like and subscribe. I'll talk to you soon.